Hi, I'm Steve Croft. I'm a researcher here at Berkeley SETI Research Center, and I'd like to tell you today about a cool way that you can turn your computer into a radio detector, just like we do with our radio telescopes. So there's a range of these things available online. This is called a software-defined radio, and it's a little USB stick that you can plug into your computer, which will take signals from an antenna. This one actually came with an antenna. I picked this up for about 20 bucks online, and it takes the signals from the antenna, digitizes them, and enables you to see a visual representation on your computer screen of the signals that you're picking up, particularly in the FM bands. You can pick up regular FM radio, the same as your car radio or radio at home does. You can also pick up signals at different frequencies depending on the USB stick that you buy. They have different frequency ranges. Police radio, you could pick up drivers of your local transit system. You can pick up airplanes. You can even decode signals from airplanes, from the transponders that are telling you where the aircraft is and how fast it's moving and this kind of stuff. And there's also astronomy applications for these things too. Even you could hook them up to a bigger antenna and do some radio astronomy at home, detecting the sun, for example, looking at reflections of radio stations off meteor trails. There's a lot of instructions online that will tell you more things that you can do with these. But to start off with today, I'd like to just show you how this software-defined radio dongle works. So I'm just going to pull a little cap off here. You can see it's just a regular USB stick. I have the antenna that came with it, which I can plug into the edge of the stick here. And then I'm going to plug this into my computer, into the USB port here. Put the antenna down and then fire up the software. So the software that I'm using is called GQRX, and I'm running this on a Mac. There are various other options for doing software-defined radio, again, that you can find online. So I've opened a terminal window here. I've installed the GQRX software. Then I'm going to launch GQRX here, and you'll see the graphical user interface for GQRX come up here. There's a little power button up at the top. Just going to turn my volume down. Turn the power button on here, which is now receiving the signal from the antenna here. So there's a digital signal processor, which is digitizing the FM signal. I'm tuned here. We're in Berkeley, California, and I'm tuned into our local NPR station. Shout out to those of you at KQED, which is 88.5 megahertz, and you can see on the screen the frequency 88.5 here, and you'll see at the top there's a graph showing the intensity of the signal as a function of frequency. So running from 87.995 on the left through to 89.045 on the right. And here in the center of the band, you see at 88.5, this is the signal coming in from KQED that's being digitized by the antenna here. I can turn the volume up on my laptop. And you can see, along with the representation here of the signal that's coming in, this FM or frequency modulated signal, we're also getting the waterfall plot. We're getting the scrolling down here of the signal as a function of time and frequency, and we're getting the sound coming out of the speakers here too. I can drag this this window here where we're picking up the signal off to one side, and you'll actually see the waterfall plot is still scrolling down, but now we're picking up this region of noise at the side here. There's basically, here is some digital information which just sounds like noise that goes along with the KQED analog signal, or I can pull this off the band completely here, just sort of out into the background, and we're just picking up general background radio noise, the white noise, which really is sort of the hiss that you hear everywhere. If you turn a radio telescope to the sky, most of what you're picking up is white noise. It's this background signal that has no evidence of an engineered narrowband signal, like is obvious here on a waterfall plot. If I tune back across again, and we pick up KQED again. So I can type in another frequency here. I can tune to a different band. Let's try 98.1. And now we're picking up a music station. You can see the signal looks pretty similar. I can change the bandwidth here. The digital information is still here on both sides of the analog information in the middle of the band here. Again, I can tune off to one side. Just as you would do when you're tuning your car radio between stations, you start to hear the noise and then it comes back again into the sound that we're picking up there from the station that we're intending to pick up. So we're picking up here radio stations that are broadcasting from really just from within a few miles here of where we are at Berkeley SETI Research Center here on the Berkeley campus. So what you can see here is a part of the spectrum where we have 2 radio stations that are showing through here, one at about 99.7 and one at 98.9. So I can tune from 99.7 to 98.9, and now we're listening to this station over here on the left of the screen. I can tune to the noise in the middle of the band here. You can see there's a few faint things coming through. Again, there's the side bands here from this analog signal, and then I can tune back to the analog signal again. And I think that's should be obvious. But what if you were to attach some digital hardware like this software-defined radio up to a very powerful radio telescope that can pick up sensitive signals from the sky? Well, as I said, mostly you would hear background noise, but if you were to tune your radio that's hooked up to your radio telescope and point at a specific position in the sky, and you start seeing this sort of narrowband signal that is a signature of an artificial signal that is engineered, that's an evidence of intelligence, and then you were to move away from that position on the sky and the signal went away, and you move back and the signal is still there, then that might be a good candidate for a transmission coming from beyond the Earth. It may be something like a satellite if you pointed at a satellite in Earth orbit, but really the signals that we're trying to find are kind of similar to the signals that we're picking up here with these FM radio signals with our software-defined radio, but we're trying to find signals that are engineered by civilizations other than our own that are coming from planets orbiting other stars. And that's really the goal of what we're doing here, not just picking up FM signals, but really tuning across the radio band and also looking in the optical too with other telescopes like the Automated Planet Finder. But we're trying to find signals that don't look natural, that look like they're engineered, and that's really what the basis of our search.